What's up, geometry? Did somebody say systems practice? That's exactly what we're going to be doing in today's video. So go ahead and take out something to write with in your notebook because we're going to take some notes. Okay, so here we've got a system in the context of a geometry problem. So we have expressions for all of our angles and they want us to solve for x and y. So I'm looking at these two pictures and the first thing that I want to think of is what are the equations that I can make so that I have two equations so that I can solve my system. So I'm going to look at this first diagram here and I see that I've got a straight angle. If you guys remember, straight angles equal 180 degrees. So this whole angle equals 180 degrees. Well, that whole angle is comprised of this angle and this angle. So one of my equations that I can set up is 4x plus 56 plus 5y plus 27 equals 180. Okay, from there, I'm just going to go ahead and simplify what I can. And so that just means I'm going to combine this 56 and the 27. So I've got 4x plus 5y plus 83 equals 180. And when I'm solving systems of linear equations, I want all of my x's and y's on one side of the equation if I'm solving using elimination, which it looks like I'm going to solve using elimination. So I'm going to move that 83 to the other side. I'm going to get rid of that. So I'm going to subtract 83 on both sides. And so my final equation using that first diagram is 4x plus 5y equals 97. Okay, so here's equation 1. Okay, so now the next thing I want to do is look at the next diagram, which is right below that. And I see I've got two complementary angles. And if you don't remember what complementary means, it means that both of those angles add up to 90 degrees. And I know that they add up to 90 degrees because this angle right here is a right angle. How do I know that? That box right there gives it away. This little box in the corner here, that tells me that this is a right angle. Right angles measure 90 degrees. So I know that if I add this angle and this angle together, they're going to equal 90 degrees. So the equation that I can set up here is 2y plus 14 plus 3x plus 12 equals 90 degrees. And we're going to simplify like we did before. So we're going to do 14. We're going to combine that 14 and 12. And so I get 2y plus 3x plus 26 equals 90. And I'm going to move that 26 to the other side. So I get 2y plus 3x. Whoops. I want to show my work. Subtract 26, subtract 26. And so my final equation for that second diagram is 2y plus 3x equals 64. Okay, but I'm just going to switch the places of the x's and the y's. So I'm going to keep this as 3x plus 2y equals 64. Okay, so I've got equation 1 and equation 2. So I'm going to look at all of the coefficients. And if you remember, the coefficients are the numbers that are in front of the variables. And I don't have any coefficients of 1 in front of any of my x's and in front of any of my y's. I've got a 4 here, a 5 here, a 3 here, and a 2 here. So that means that I'm going to probably want to solve this system using elimination. And so what I'm going to do to start solving by elimination is, if you guys remember, we want to stack our variables. We want to stack our equations. So I'm going to copy down the equation. So I have 4x plus 5y equals 97. And we've got 3x plus 2y equals 64. Now, when we're solving using elimination, I want one of the variables to have the same coefficient. I don't have the same coefficient right now, so that means I need to multiply both of those equations by a certain number. It doesn't matter which variable you choose to eliminate. I'm going to choose to eliminate my y's. So I'm going to multiply this entire first equation by -2. And I'm going to multiply the entire second equation by 5. Now, the reason I'm choosing those numbers is because, and you'll see in just a moment, So I'm going to distribute that -2 to everything in the red equation. So I get -8 minus 10y equals 97 times -2 is -194. And I'm also going to distribute the 5 down here to everything in the blue equation. Okay, so I end up with 15x plus 10y equals, let's see, 5 times 64. That's going to give me 320. Okay, now the reason why I chose the numbers -2 and 5 is because then when we did that, if you notice, our y's now have the same coefficient, which is what we wanted, which is what we need when we're trying to solve using elimination. And I made one of these numbers negative so that I can just add both of my equations. Okay, so now let's focus back on our system over here. So I've got the same coefficient in front of my y's. One is positive, one is negative. So I'm going to add everything. I'm going to add those equations together. So I'm going to do -8x plus 15x, and that's going to get me 7x. -10y plus 10y, that cancels out, so that gets eliminated, equals -194 plus 320. That gets me 126. Okay, and then to solve for x, I'm just going to divide by 7 on both sides. And I get that x equals 18. Okay, so I've solved for x, but I haven't solved the system because you also need to find your y. So I know what my x is. I'm just going to substitute that value into one of the original equations. It does not matter which one, so I'm just going to choose the red one, the original red one that we were working with. So I had 4x plus 5y equals 97. And I know what x is now, so I'm going to do 4 times 18 plus 5y equals 97. So 4 times 18 is going to get me 72 plus 5y equals 97. We're going to subtract 72 on both sides. And I end up with 5y equals 25. Divide by 5, divide by 5, and we get that y equals 5. So my solution to the system is that x equals 18 and y equals 5. If you're writing this as an ordered pair, then we can write this as 18, 5. And that is your answer. We've answered it. Okay, if you need to, go back and rewatch any of these parts of the video that you need to, and just make sure that you're taking notes. Thanks for watching.